Hey lifeguard, wake up. There's a swimmer needing rescue 200 yards down the beach and 25 yards offshore. Get going. Okay, what do you do? Well, let's make a plan and consider alternatives. First of all, what you could do is that you could make a green line that goes straight towards the swimmer. Or maybe you're going to run all the way as far as you can and then swim straight towards the swimmer. Or maybe there's an alternative where you run a little bit ways down the beach and then you swim the rest of the way. Okay? Exactly what would you do? Well, let's make some assumptions. Let's assume that you can run down the beach at 400 yards per minute and swim at 50 yards per minute. How far do you run before starting to swim? Okay, so with this, let's suppose that we run a distance x down the beach, and then we're going to have 200 yards minus x that we have not run, and that we're 25 yards out. So then we would we'd have to swim along this diagonal of this right triangle. Gee, I wonder how we're going to figure out what that would be. Well, the Pythagorean theorem to the rescue. Of course, if we have A and B and C, then of course C squared is equal to A squared plus B squared. The Pythagorean theorem, so C is the square root of A squared plus B squared. And so this one would be square root of 25 squared plus 200 minus x, quantity squared. Okay, the time it takes to get from Y to S, where you are and where the swimmer is the time spent running x yards and the time spent swimming that distance of yards. Since time is distance over rate, the total time spent is a function of x, would be x over 400, because you were able to run at 400 yards per minute on the beach. And then you're swimming at a rate of 50 yards per minute. And so that'd be the square root of 25 squared plus 200 minus x quantity squared all over 50. And of course, x is somewhere between 0 and 200. The derivative would be 1 over 400 plus 1 over 50 times, and we're going to take the derivative of that radical function. So square root of, that's something to the 1/2 power, so the derivative will be to the negative 1/2 power. 25 squared plus 200 minus x quantity squared. And then we would have to use the chain rule, so we're going to have to take the derivative of what's inside. So it would be 200 minus x times 2 times negative 1. And so we've got the derivative there. Of course, we're going to want to know the critical points. So the derivative would be 0 precisely when 1 over 400 is equal to 1 over 50. And then we have the same expression here, except without the minus sign. Multiplying both sides by that radical, we would get radical over 8 is equal to 2 times 200 minus x. Of course, if we multiply by 50 on both sides, we can tell where the 1 over 8, where the denominator of 8 comes from. Squaring both sides to get rid of the radical, we have 25 squared over the quantity 200 minus x squared over 64 is equal to 4 times 200 minus x. Oops. And now multiplying by 64 and subtracting f1 200 minus x squared, we would have 255 times the quantity 200 minus x squared is equal to 25 squared. Divide by 255, take a square root, and we would get 200 minus x is plus or minus the square root of 625 over 255. In other words, x is equal to 200 plus or minus the square root of 625 over 255. Remember, we said our x has to be less than or equal to 200, so we're not going to bother to add anything to the 200 that we've got there. Excuse me. X has to be less than or equal to 200. We'll only subtract it. And that comes out to be about 198.43. So remember that optimization technique we had for on a closed interval? x could be 0 or 200, that's the endpoints. Or it could be this new critical point that we found, 198.43. Of course, if x is 0, we could plug that into our original function f that we had way back at the beginning of this problem. If x is 0, of course this is 0, and then we would end up with 0 here. We'd have 25 squared plus 200 squared. Add that together, take a square root, divide by 50, and that comes out to be about 4 minutes. That's basically you're swimming the whole time. If x is 200, that's half swimming, half a minute swimming, half a minute running, and for a total of 1 minute. And if we have this thing where you run almost all the way down the beach, 198.43 yards, and stop a little bit short of that, then we would only have to go 0.997 minutes. Okay, not much, but in circumstances like this, every part of a minute counts. So just by hair, it's better for you to swim instead of running the full 200 yards.